Assuming that you're working with a system which employs multiple processor cores, and let's say there are three processor cores, core 1, core 2, and core 3, and they are all interconnected to memory. So assuming that this is memory, they're all interconnected. Now core 1 wants to write a 0 to memory, core 2 wants to write a 1 to memory, and core 3 also wants to write a 1 to the memory. In this case, what would happen? See, when core 1 wants to write a 0 and core 2 wants to write a 1, there is a conflict, right? Because you do not know if this should be a 0 or a 1. There are several problems that are associated with this. The first problem is maybe 0 is written faster to memory compared to 1, but instead the memory should have been written by 1. Therefore, there's a problem of memory corruption. The second problem is due to these 0 and 1 ambiguities, the circuits might get short circuited. So you have short circuit issues. To avoid these problems, we use something known as tri-state buffers. They are also known as three-state buffers. Before looking into tri-state buffers, let us go back to what is a buffer. If you remember, a buffer was used to increase the fan out, and the symbol for a buffer was this one here, AF. So if A equals to 1, then F is equals to 1, and if A equals to 0, F is equals to a 0. Right? So we use buffers to improve fan out. Next, we come to the concept of a tri-state buffer. So the symbol for a tri-state buffer is as follows. So you have the buffer A, F. With a tri-state buffer, you have another input called the enable input. So when enable equals to 0, F is equals to a Z. Z indicates high impedance. And when enable equals to 1, F gets the value of A. So if you write it in a truth table form, it's going to be enable A, F. You can have four combinations, 0, 0, 0, 1, 1, 0, and 1, 1. When enable is 0, your output is high impedance. So basically in high impedance, what happens is A is totally isolated from F. So there is no physical connection. When I say active high, it means that when enable is 1, then it acts as a buffer. And when enable is 0, it's high impedance. So this is the concept of a tri-state buffer. Now, how can we use a tri-state buffer to prevent data corruption and to prevent short circuit issues?